Is it time to consider 5G technology mainstream and worth investing in for your boat or RV connectivity arsenal? Come join us for our annual dive into the state of cellular technology and how the carriers' networks are evolving and growing. Stay tuned. Hi, I'm Chris with the Mobile Internet Resource Center, here to give you our annual deep dive into the state of cellular technology, letting you know how the networks have been evolving, how hardware has been evolving, and well, what's coming next, what's down the pipeline. And well, of course, we are in the midst of the 5G era. We've been 4G's in the past, 6G is still far over the horizon, and well, 5G is now reaching what is known as 5G phase 2 of the evolution of 5G hardware. And we consider this to be kind of the sweet spot where basically 5G is getting mainstream. It is now no longer a premium feature. It is now no longer something to stretch for. It is something that is certainly worth investing in. If you're buying new hardware now of any sort, probably time to make sure that it is 5G. And in particular, it's worthwhile investing in 5G now because the cellular carriers, their networks have started to get really good and over a much larger area of decent 5G coverage. It's no longer 5G that is sort of maybe better than 4G, maybe not, and only really good 5G in core urban areas. Now, a lot of times you can be out in some rural and suburban areas and have some amazing 5G. But it's not all carriers created equal when it comes to the state of 5G networks, and not all 5G hardware is created equal either. Particularly if you have any of the 5G hardware from the first generation of 5G, you might be, well, kind of left behind as the networks continue to evolve. So let's dive in a little bit deeper. So to understand how 5G technology has been evolving, it helps to think about the technical standards that are behind the scenes. 5G isn't just, well, the fifth generation of cellular. It is behind the scenes. It is the 15th evolution of the cellular industry standard. So 15G just probably wouldn't have had that same ring. But so 5G was defined as the 3GPP Release 15 specification was the first 5G devices. This was a cellular standard that took a big jump above 4G, started to do new things with cellular spectrum, and opened up a whole new wave of performance. But the Release 15 standard was just to get 5G out the door. And for the most part, the initial 5G networks were kind of a performance layer built on top of existing 4G networks under the hood. To truly unlock the performance of 5G, the 5G networks have been evolving to be able to run in what they call 5G standalone mode. That is, means no more 4G network required behind the scenes, so the carriers can start repurposing 4G spectrum and devoting it specifically to 5G and offering lower latencies and more of the capabilities that 5G was designed to deliver. As that standard evolved, as they learned from that first generation of 5G, the next generation of the standard was, Release 16. No catchy name for that other than the industry tends to call it 5G Phase 2. So that is, 5G, we learned from everything, we got it out the door, and now it is mature technology. And that is kind of the point we have reached right now. And when it comes to the modem chipsets that power all sorts of 5G devices, from smartphones to cellular integrated routers to hotspots, the modems have been evolving. So the first 5G phase 1 modems were the X50, X55, and X60 were the modem chipsets from Qualcomm, who is the 5G modem leader. And they were great. The X55 has been in a whole lot of devices. But we've been waiting for this 5G phase 2 when the technology gets more mature and will be more future-proof. And we'll kind of reach that point over the course of 2023, where now almost all of the cellular router manufacturers have devices that support 5G phase 2 by using the next generation of modem. So Qualcomm's products, that's the X62 and X65 modem chipset. So now we've got kind of a new plateau of technology that has been reached. And just like when LTE was evolving a decade ago, the first few generations of LTE, the first few series of modems, the Category 3 and Category 4 modems, were kind of limited in what they could do. And then the Category 6 came out, and that became the foundation that lasted. It was still on the market, still people shipping Category 6 LTE devices even now. So it became a baseline that lasted a very long time. And we're kind of expecting the same sort of thing to be happening with 5G hardware. So this second phase of hardware, the things X62 or X65 and better, is going to be viable and valid for a long time. And the limitations that we've pointed out every year about the X55 generation will hopefully become a thing of the past. So this is where you start to think about, is it time to invest in hardware? It's like, yes, it is, but make sure you're investing in hardware that is on that phase 2 hump or better. So stuff to keep in mind there. Now, to understand more, like, so what were the limitations? What was the big changes? Some of the things that the newer generation can do that the older generation cannot. There's two key things that we've continuously pointed out. The one thing is that the older generation of hardware, the X55 era of hardware, can not combine two different 5G bands together. It has 5G carrier aggregation. It can do a lot of things with it, but it could only combine very specific combinations. And in particular, it could not combine low-band, long-range spectrum with mid-band, high-speed spectrum. So you could not have, basically unlock the potential of high 5G, high performance over a longer range, because you couldn't combine your long-range uplink signal from your router with the faster 5G mid-band coming down from a tower. So the 5G Phase 2 devices, the next generation of hardware, can combine those long-range and the mid-range signals. So that is a pretty substantial change in evolution there. Then the other thing that has evolved quite a bit is the next generation, the 5G Phase 2 evolution of hardware, has support for a lot wider range of 5G bands and spectrum. So that means it can support more devices, more carriers, more network expansion. And basically, the generation of hardware we're seeing now supports all the 5G bands pretty much that most of the carriers are pushing in the United States. So this means like hardware like Dish Network, they're using some kind of oddball bands that were not supported in the X55 era. The newer generation of devices do support the bands that Dish Network is using. And the most important band that the newer hardware supports that the older hardware does not is for AT&T. Now, AT&T, we've talked about this several times in the past, has bought a whole bunch of spectrum that industry analysts call the Andromeda spectrum. It's kind of a piece of the C-band that was kind of set off to the side, a little bit different than the rest of the C-band that Verizon has been using, for example. And AT&T's Andromeda spectrum is just fundamentally not compatible with the older generation of hardware. So if you want to have hardware on AT&T that can take advantage of where the bulk of their 5G expansion is going to be, you need to have this newer generation of hardware. So there's a lot of evolution that's been happening here, and we've kind of crested and reached this new plateau. And the old stuff, X55 era, will work great, performs great, fabulous modems, but we're now at a new era where things work and are more flexible and more capable. And for the case of cellular integrated routers, we've been waiting for years for this era of hardware to make it down from phones. We saw phones several years ago to hotspots last year that had that X62 or X65 hardware in them. And now in 2023, we're finally seeing the cellular integrated routers have this era of hardware in them. And well, when you're investing in potentially multiple thousands of dollars in a like dual 5G router like this Peplink Max BR2, you want something that's going to last 3, 5, 7 years of good viable use. So we've now crossed that threshold where things will have a longer shelf life, a longer period of future proofing before they fall too far behind. So we consider it's like you're investing in very expensive hardware. We've now reached that plateau of a good time to consider that. But there are still some potential catches here, and that involves, well, it's the X55, X62, and X65. Let me explain those three chips a little bit more. One thing that is kind of, if you dive deep into the technical specifications of a modem like the X55 that was in the prior generation of the Max BR2 Pro, It claimed a max theoretical throughput of 7.5 gigabits per second, a pretty insane speed for cellular throughput. And then you look at the new generation of Max BR2 Pro and the X62 chip that is in it, and it claims only a max theoretical speed of 4.4 gigabits per second. Wow, it's like barely over half the speed for the new generation of modem. What's going on here? And well, that difference is because the X55 was a flagship modem. It was the pinnacle of the 5G phase one generation of hardware. And the X62 isn't the true sequel of the X55. The X65 is the flagship of the 5G phase two generation that is out. This is a Qualcomm's flagship modem that is capable of 10 gigabits per second of throughput. It's a significant advancement of technology there. The X62 is the mainstream cost-reduced version of this, designed to make 5G suitable for a wider range of more mainstream devices. And so the X62 is a step down when it comes to peak theoretical speed, even though it has more technical capabilities behind the scenes. And well, those peak theoretical speeds are only applicable when these modems are deployed attached to millimeter wave 5G antennas. This is the super short range 5G technology that is really only appropriate in places like stadiums, airports, super dense city centers, and other places like that. The places RVers and boaters go, millimeter wave is not likely to be important anytime soon. And well, millimeter wave is not practical to build into a cellular integrated router like this because you have this router mounted inside your RV and you have antennas on the roof connected instead of like these directly. You have antennas connected upstairs to antennas on the roof over 10 or 20 feet of cable. Millimeter wave signals will only travel a few inches over antenna cables, and so therefore are completely not practical on the type of routers that our audience of RVers and cruisers is installing. So those peak theoretical speeds do not matter at all. More importantly, when you're comparing the X55 with the X62 and the X65, is how much of the mid-band and low-band spectrum can these modem chipsets work with? And that's where their differences are a little bit more interesting. The X55 can work with 200 megahertz of 5G spectrum at once, and it can combine two different channels together in some very limited ways. As we talked about, it can't combine mid-band and low-band together. So it's very limited in what it can do with those two different channels of spectrum. The X62 and X65 can combine 3 channels of 5G spectrum together, so much more flexible in how many different combinations it can make, and it can combine different types of spectrum. So it can combine the mid-band and the low band together and be much more flexible in what it can use. But then how much spectrum can it use? The X65, the high-end flagship, can use 300 megahertz of spectrum. So that can deliver a lot of potential performance. It's the spectrum, you can think of it as lanes of highway, invisible highway through the sky. So 300 lanes of invisible highway that it can tap into and combine. The X62, which is now what all the cellular integrated router manufacturers are using, is actually still a step down from the X55. It can combine 120 megahertz as opposed to 200 megahertz. So it's a step down because it's the more mainstream low-cost part, and it has a regression there. And so that means what we're kind of saying is that X62 generation of hardware in cellular routers is 2 steps forward. You got a lot more flexibility and capability. You're compatible with the next generation of standards. You're going to have hardware that's going to be suitable for the long run of 5G for years to come, but it's 1 step back. The modem can only combine 120 invisible lanes of 5G as opposed to 200. Is that actually a significant step back? We suspect there will be a few real-world locations with really strong mid-band signal where the older X55 might be able to deliver performance that exceeds the X62, but we also suspect that in the vast majority of real-world cases, the X62 will likely be more capable, particularly in weaker signal areas where it's able to do a better job of combining the signals that are out there. But again, this is stuff that we're just now hoping to see in real-world testing. Now that we've got an X55 and an X62 version of this router. We're putting them head to head, and our members can follow along and see if we are able to find any interesting regressions. But theoretically, we think the X62 is actually a pretty acceptable chip for cellular integrated routers, particularly since the most of the current generation of cellular routers out there couldn't actually handle much performance exceeding a gigabit per second anyway. The routers would be the bottleneck, not the cellular network. So not too much to stress about, but something to know. And then, well, you get the question is, well, why didn't the router manufacturers go with the higher end flagship X65 chip that can handle way more mid-band spectrum and low-band spectrum? And probably a couple reasons, not just because the X62 is cheaper. It's mostly just that the X62 is available now, is FCC certified, and the modules are available and has been carrier certified. So I don't think any of the device manufacturers wanted to wait another 6 to 12 months just to have potentially higher peak theoretical speeds. So again, we'll see if anything comes up in our testing. Members, stay tuned for our testing forums. But again, now you understand the potential trade-offs and, well, the potential evolution of how these go. There might be X65 modules percolate down into cellular integrated routers at some point. In about a year or 2 or 3 from now, we'll see the next wave of cellular integrated routers with a new wave of modules. That would be X72, as Qualcomm's a next iteration of cellular standards at what they call 5G Advanced that will be suitable for cellular integrated routers. Again, that's just like LTE went to LTE Advanced. There'll be 5G and 5G Advanced. There's probably not reasons to continue to wait for that generation of hardware. We're at that nice plateau now with this 5G Phase 2 where we're currently at. Now, let's take a look at what the cellular carriers are doing and how their networks are, because it doesn't matter what your hardware can do if, well, how is the state of 5G from the carriers themselves? Diving into the cellular carriers, the big 4 carriers in the United States are T-Mobile, Verizon, AT&T, and Dish, the newcomer. How are their 5G networks coming along? Is their 5G worth using and investing in and having in your connectivity arsenal? And it is currently, well, they all are in very, very different places when it comes to the evolution of their networks. So T-Mobile, from the very beginning, has been the leader in 5G. T-Mobile invested early on to get a lot of low-band spectrum, band N71, that gives them the long range, and then they acquired Sprint, and for the prime purpose of getting a bunch of mid-band spectrum that Sprint controlled, that gave T-Mobile this band N41. So they had a lot of mid-range 5G, and they have been aggressively rolling this out. And it has paid off. T-Mobile is kind of the world leader when it comes to pushing 5G technology. They're the first to do a 5G standalone network, so they're running 5G without needing 4G underneath it. They were the first to now demonstrate 4-way 5G carrier aggregation, combining 4 different 5G channels together. And they've been delivering some really, really impressive performance over a much wider range than the other carriers. So if you are wanting great 5G performance, or you are a T-Mobile customer, you really want to have some next generation 5G hardware that can tap into the capabilities that they're pushing. But the other carriers are catching up. The Verizon and AT&T, the core of their next generation 5G networks is based on mid-band C-band spectrum that was kind of had incumbent users. Satellite industry was using this, and they had to wait for the incumbent users to move off, transfer their satellites, launch new satellites, basically to clear the airwaves so that the C-band would be available for use. And that has kept Verizon and AT&T kind of playing the waiting game for a while. They were able to start deploying their C-bands over the last year and 2 years, but only now towards the end of 2023 is all of that spectrum now cleared, and they have full nationwide access to start turning on more and more of this, what's truly next generation 5G. And so when you just look at the raw spectrum holdings now, T-Mobile's lead and Verizon and AT&T, they're all now back to kind of a neck and neck place. T-Mobile's just got a big head start in turning on their network. And Verizon, the story of the past year is Verizon is kind of the comeback king. They have been ramping up their 5G network and turning it on in more and more places. That has been kind of revolutionary for them. They've now gone from having 5G that was 5G in name only to having a lot of what they call their ultra wideband capacity in more and more parts of the country. They still haven't caught up with T-Mobile. They're still significantly behind, but they have gone a long way. And on Verizon, 5G is very, very worth investing in and definitely worth having plans that could take advantage of this. Now, AT&T, they've also had this spectrum cleared away, the C-band spectrum and this Andromeda spectrum that they've purchased. But cellular industry analysts have kind of noted that AT&T seems to be dragging their feet in actually building the towers and deploying the spectrum. So when it comes to 5G, AT&T is kind of the least worthy network. They don't have a lot of truly next generation 5G coverage turned on. They have a lot of places where you'll see a 5G signal, but it is then combined behind the scenes by the modem with a lot of 4G. And you'll get some really great performance, but you'll also get basically the same performance with a high-end 4G device as well in those places. So AT&T's network has still got a ways to go, but sometime going into the year ahead, they're going to have to start, making all their investments pay off and turn on spectrum in more places. So again, AT&T been holding back, but they're going to be turning on 5G in more places, and they have a lot of spectrum that is just waiting to be kicked into high gear, and we're expecting some good things in the future from AT&T. So that's kind of the state of where the carriers' networks are. T-Mobile way up here, Verizon rising rapidly, AT&T down here. And then, well, there's a fourth carrier, Dish Network. Now, part of the merger agreement between Sprint and T-Mobile back years ago was that T-Mobile had to give up a whole bunch of spectrum rights nationwide to enable a new fourth nationwide carrier, and that is Dish. And Dish had certain legal requirements to deploy their network over a coverage of a certain number of people by a certain date and have a 5G network. And they just by the skin of their teeth managed to do that. They now have a pretty sizable network, but they have a lot of growing pains. Their network it's kind of more of a Swiss cheese network, has a lot of holes in it. It's not something that's going to give you a ton of great coverage. But when you are in some place where Dish native 5G exists, their network was designed from the ground up with no 4G. It is a 5G standalone network that is completely native and it can perform incredibly well, particularly because they have so few customers, there's not a lot of congestion out there. The catch with Dish is it's not going to ever want to be anytime soon your only network, but we found it to be a great companion to the other networks. And when you're using their plans in a 5G router, you can get some really great performance, and their plans roam onto AT&T with no throttling. So we often get some really great access to AT&T's network too in the places Dish doesn't have coverage. Now, because Dish is still kind of in this evolving, awkward phase, their plans are very affordable. They've currently suspended the availability of their mobile data plan. So currently at the end of 2023, their smartphone plan is the only one available, but we're hoping they'll bring back their mobile data plans for hotspots, and you could potentially put them in routers as well in the not too distant future once more compatible hardware is available. And well, that's kind of the state of Dish. So that's all the carriers now are kind of really 5G centric in how they're evolving, and definitely you want to be able to take advantage as these networks continue to evolve and grow. What's coming next? What's the future forecast? What's going to happen to 5G in the years ahead? And well, just like 4G, 5G was designed to be an evolutionary technology that would, evolve in phases. As I said, we're currently release 16, which is 5G phase 2. And coming up in the next few years, there is what's going to be known as 5G Advanced. That's release 18 of the standards. Release 17 is going to be kind of an interim release that is focused on capabilities talking to satellites. So we'll talk about that in a second. But the release 18 is going to be the marketing term 5G Advanced. And that's going to be kind of unleashing a wave of next generation higher end 5G devices and new capabilities behind the scenes. Again, not too much to worry about, but you'll see the marketing around that begin in the next year, 2 or 3. And slowly they'll become the higher end of the market. And then the current 5G phase 2 devices will be 5G. So just like LTE and LTE-A, we saw that in the 4G era, we'll see 5G and 5G-A kind of coexisting as mainstream devices, high-end premium devices going forward. Further down the line, well, there is of course going to be a 6G. The cellular generations are basically designed to every decade there is a jump to a new standard that changes and in some incompatible ways how the radio devices can communicate with each other. And work on 6G is already well underway, trying to define what this next jump will be. But that's really not something that's going to be coming to market until around 2030, slated to be release 21 of the cellular industry standard. So 6G, it's in the pipeline. It's coming 2030. Don't be too worried about it anytime soon. We do get asked, though, people who are worried about it is like, well, what about all my existing 4G gear? Is that going to go away? Is that going to be disconnected? Are the carriers going to pull the plug on 4G just like they've done pulling the plug on 3G over the past year, and 2G and all these other older networks have been shut down? So hardware that was 3G only is basically useless now. And we don't expect 4G networks to be shut down anytime soon, even in the fairly long-range future, because 4G and 5G and 6G were all being designed to layer on top of each other and evolve in a kind of continuous fashion, just like how DVD went to Blu-ray. So VHS and a DVD player and a Blu-ray player, there's a break there. VHS and DVD, completely different formats, but a DVD will play in a Blu-ray player. A Blu-ray won't play in a DVD player. And that's going to be the way to think about your 4G devices on 5G networks, and very likely even on 6G networks going forward, is there will be spaces carved out on the network for 4G compatibility. Now, some 4G spectrum will, and is already starting to happen, will be converted to be dedicated to 5G. Some of the other spectrum will be used in using dynamic spectrum sharing to layer 4G and 5G on top of each other. But because that dynamic spectrum sharing technology exists, there will probably always be at least some 5G spectrum and eventually some 6G spectrum that is kept around for 4G compatibility. So now it's not something you really need to worry about with your older devices. Now, some other things that are on our radar is that people are getting excited about is satellite direct to cellular compatibility and connectivity. Now, Apple has pioneered that with the iPhone 14 and 15 using kind of a special radio and a special partner with Globalstar to do very, very limited connectivity for basically emergency use only, to get help when you have no cell coverage, or whether auto breakdowns or the equivalent of 911. But there's actually several companies that are working on technology to allow satellites to be cell towers in space for regular, non-regular everyday 4G and 5G cell phones to provide direct connectivity. And there's some interesting partnerships forming. We covered a year ago T-Mobile and Starlink bringing out a partnership called Coverage Above and Beyond, and they're pushing to begin in 2024, launching some test satellites that will basically have a T-Mobile cellular payload or a cellular payload riding along on next generation Starlink satellites to give some connectivity to T-Mobile customers. Verizon has an announced partnership with Amazon's Project Kuiper, which will potentially start launching in the not too distant future as well. And then AT&T is working with a company called Space Mobile, which has been demonstrating from satellite to cellular connectivity, and has actually shown it working with making voice calls and doing text messages and stuff to a regular everyday phone. But again, these are all just kind of in the test phase going into 2024, other than the kind of emergency use only service. The real connectivity from cellular to satellite is still a long ways away. And when it does roll out, people think it's going to be like magic broadband from the sky. And it's not. It's going to be the satellites will be providing wide area coverage to fill in the gaps in the cellular networks, and the data speeds will be relatively slow, actually significantly slow for the first many years of this sort of deployments. So you will not be video chatting or doing gaming or big downloads over a satellite to cellular connection, but you might in the next 2 or 3 years be able to post an Instagram photo. So some exciting stuff coming. The cellular networks are evolving. The cellular companies and the satellite companies are starting to partner up, and it's an exciting time to see all this technology continue to evolve. Now, to wrap all this up, people keep asking us, is it time to upgrade to 5G? And well, if you haven't yet, it probably, certainly there is no reason to hold back now with the new generation of hardware and the current state of networks, because the hardware and the networks will just keep getting better, but now is a worthwhile time to be a part of it. If you have already made the jump to 5G and you have like the X55 era of hardware on cellular routers and stuff, I wouldn't encourage you to rush out and upgrade again immediately, because this is like the evolution is like a relay race. They're handing the baton to the next generation. And currently, you're probably not going to see a hugely dramatic differences in a lot of places. So no, really, unless you like being on the bleeding edge and you've got an easy way to sell your old hardware, don't necessarily need to rush out and upgrade immediately. Maybe wait another year to see what comes out after that. But if you haven't made the jump yet, never been a better time to be on board 5G for RV and boat use. The networks are now covering enough places. The hardware is now good enough and will be good enough for a longer time into the future that you can officially say the brakes are off, go to town, have fun with 5G, and enjoy these things keep getting better. Now, I want to wrap up by thanking our members at the Mobile Internet Resource Center. We call them the Mobile Internet Aficionados. They're the ones who make content like this possible, and we share a lot deeper analysis and testing notes with them in the forums and in all the other places. So if you are interested in this level of geekery and tracking the technology and what is possible and what is coming, please consider coming to join us over at the Mobile Internet Resource Center and become one of our members to support us. We are not driven by advertising or affiliates or any sort of relationships like that. That's why we are able to be unbiased and play with so much different gear and hardware and not show allegiance to anyone other than to supporting our members. So please come join us, and well, may the bandwidth be with you, and welcome to the 5G world. How's water's fine, jump on in.
These videos are brought to you by our premium members, our Mobile Internet Aficionados. They make it possible for us to track this news and create these videos. If you like this video, please give it a thumbs up, leave a comment, subscribe to our channel, or better yet, consider becoming a member yourself.